السلام عليكم ورحمة الله وبركاته. بنعمل مراجعة لجريد 12 Advance. Choose the correct answer. Question number 1. The car batteries are rated in the unit is called amperes hour. What does this unit represent? Ampere hour. Ampere it mean current. I. Hour it mean time. I times T equal what? Exactly equal Q. So that ampere hour it represents electric charge. Question 2. Battery written on it 9 milliampere hour. Ampere hour it's a charge, so that Q equal 9 milli multiplied by 10 to the negative 3 hour multiplied by 3600. The answer will be 32.4 coulomb. How much time? He asked about time. Time in second. We can convert from second to hour by divide 3600. How much time is required for this battery? By providing us with a constant current of intensity 0.4 milliampere, so that it's I. Second step, I equals 0.4 milli multiplied by 10 to the negative 3 ampere. All of us know this equation. I equal Q over T. T equal Q over I. So that T, the time is Q 32.4 coulomb. Divide 0.4 times 10 to the negative 3 ampere. The answer equal 81000 second. I need to convert it to hour. Divide by 3600. The answer will be 22.5 hour. We can solve it directly by this equation also. Time equal Q over I. Q in the question is 9 milliampere hour. I is 0.4 milliampere. Milliampere cancelled with milliampere, so that it equal 9 divide 0.4. You will get the same answer is 22.5, and the unit is hour. Question number 3. Car battery written on it 60 ampere hour. It mean Q. We can convert it if we need, or not. How much constant current? He asked about current that battery can provide us if it's work continuously for 24 hours. This is the time until the battery is discharged. So that I equal Q over T. Q is 60 ampere hour. Divide time 24 hour. Also we can cancel hour with hour and use your calculator to get the same in the final answer. I will be equal 60 divided 24. The answer will be 2.5 ampere. Question 4. A bolt of lightning has electric current. Electric current is I when hits the ground. If the lightning lasts for 14 microseconds, its time micro multiplied by 10 to the negative 6. The amount of a charge that is transferred to the ground, the amount of a charge, he asked about Q, equal what? Coulomb. The same equation, Q equal I multiplied by T. It's equal 3.5 times 10 to the power 4 multiplied by 14 times 10 to the negative 6. The answer will be 0.49. It's around 0.50 coulomb. Question 2.1. Charges are flowing through a wire of a cross-sectional area. This is the area, centimeter square, so that I will convert it to meter square, multiply by 10 to the negative 2 square, it means 10 to the negative 4. The quantity of the charge varies with time according to this function. This is Q as a function of T, where the amount of a charge is calculated in coulomb and the time in second. What is the current density through the wire at t equal 3.5 seconds? First step, we can find I equal dq over dt, derivative of a charge respected to time, so that the derivative for this equation is 2 times 2 equal 4t plus 3. It means I at time 3.5 second equal 4 multiplied by 3.5 plus 3. The answer will be 17 ampere. The second step, J, current density is J, measured in ampere per meter square. J equal I over area, so that it's equal 17 over 1.5 multiplied by 10 to the negative 4. The answer will be 1.13 multiply 10 to the power 5 ampere per meter square. Question number 2. The number of charges that flow through the wire of a radius. The radius is r, millimeter multiplied by 10 to the negative 3 meter. Each second, it means the time equal 1 second, is 4.5 times 10 to the power 19. It's the number of a charge. The number of a charge is, so that number of a charge is n. Calculate the current density J equal what? Ampere per meter. The first step is Q. Q equal N multiplied by E. N number of a charge is 4.5 multiplied by 10 to the power 19. E is elementary charge equal 1.6 times 10 to the negative 19. The answer equal 7.2 coulomb. The second step, I equal Q over T. It's equal 7.2 coulomb over T is 1 second. It means the answer will be the same, 7.2 but amps. The third step, J equal I over area. It's equal I over pi r square. So that J is equal I is 7.2. Area is pi multiplied by r square. R square is 2 millimeter. So that 2 multiplied 10 to the negative 3 squared. The answer will be 5.7 times 10 to the power 5 ampere per meter square. 2.3. What is the current? Current is I. Passing it through a conductor with a radius. Radius is R. 3.1 millimeter multiplied by 10 to the negative 3 to convert it from millimeter to meter. If the current density is density through this conductor is J, 5.2 ampere per meter. So that the first step, I equal J multiplied by area. From where we get this equation, we know J equal I over A, so that I equal J times A. It means J times by R squared, so that the current will be J is 5.2 multiplied by times R squared, 3.1 times 10 to the negative 3 squared. The answer is 1.57 times 10 to the negative 4 ampere. We can make it equal 1.6 multiplied by 10 to the negative 4 amp. Number 4. Which of the following equation correctly represent the electric current in terms of the current density? It's equation, you must know it. I equal J times dA, integration of J dA. I is integration of J, this is J dot dA. Question 3.1. A measure of how strongly a material opposes the flow of electric charge is resistivity. Resistivity measured in ohm meter. This is resistivity. R equal rho L over A. Resistivity equal R times A over L. resistivity depends of type of material, kind of material, and the temperature. Only type of materials and temperature. Question 3.2. The ability of material to conduct. The ability of material to conduct is conductivity, sigma. Sigma equal 1 over rho. Its inverse for rho. Sigma has a unit is ohm meter to the negative 1 to the power of negative 1. This is conductivity. Number 3, conductance has the SI derived unit of conductance is G. It's equal 1 over R. The unit of G is Siemens. Is what? Siemens, capital. And also it's equivalent to what? Equivalent to ohm to the power of negative 1. So that the conductance is G, its inverse of R, the Siemens equal 1 over O, or ohm to the negative 1. The answer will be A is Siemens and C is ohm to the power of negative 1. Question number 4. The unit of resistivity is ohm times meter as mentioned before, so that the unit of R is ohm, the unit of resistivity is ohm times meter, the unit of conductivity is ohm times meter to the negative 1, the unit for conductance is Siemens or ohm to the power of negative 1. Okay. Question number 4.1. What is the resistance, he asked about R, of the silver wire, rho equal 1.6 times 10 to the negative 8 ohm meter. The length is L, and a radius is R times 10 to the negative 3, because it's a millimeter, we need to convert it to meter. The first step, write the equation R equal rho multiply L over A. It's equal rho multiply L over pi R square. I think everything is available. Rho is 1.62 times 10 to the negative 8. L is 3 meter. Pi times R square is 52 times 10 to the negative 3 square. Use your calculator. It's 5.7 times 10 to the negative 6 ohm. Question 4.2. How will the resistance of the copper wire change if the length is tripled? L2 equal 3 times L1 is tripled. Without changing its cross-sectional area, it means A2 it's equal A1, so that from this equation R equal rho L multiply divide A. Rho is constant, A is constant, so that R direct proportional with L. If the length increases, resistance will also increases. If the length is doubled, R will be doubled. If the L is tripled, R will be tripled. So that R in case number 2 equal 3 times R in case number 1. The resistance will increase by 3 times. Question 4.3. How will the resistance of a copper wire change if its cross-sectional area is doubled? What do I mean by cross-sectional area is doubled? It means A2 equal 2A1. He asked about R2 equal what? The same equation, R equal rho L over A. R and L is constant, so that R is inversely proportional with area. If the area increases, the resistance will be decreased. The area is doubled, so that R2 equal 1 over doubled to 1 over 2 R1, so that the resistance will decrease by half. 4.4. How will the resistance and the current that flowing through the copper wire change if the radius of the wire is doubled? So that the radius of the wire is double, it means R radius in case number 2 equal to R in case number 1. This equation R equal rho L over A. It means resistance equal rho L over pi R squared. Rho is constant, L is constant, pi is constant, so that are inversely proportional with the radius. Okay, what it mean? It mean R in case number 2 equal 1 over 2 squared in R1, so that the resistance R2 equal 1 over 4 from R1, so that the resistance will be decreases by 1 over 4. What about current? From Ohm's law, we know that I equal delta V over R, so that delta V is constant, and I think all of us know I is inversely proportional with resistance. It means I2 equal 1 over 1 over 4 from I1. It means I can take this 4 and put it in up, so that I2 will equal 4 times I1. The answer will be the resistance will decreases by 1 over 4, the current will increase by 4 times. Question 4.5. The 2 meter length hollow, 2 meter is L, hollow silver has inner radius is Rn, centimeter multiplied by 10 to the negative 2 or divided by 100, and the outer radius, it means R out, times 10 to the negative 2 also. What is the resistance? He asked about R of this conductor. Rho equal 1.62 times 10 to the negative 8 ohm meter. This, I think it's copper, not silver, no problem. R equal rho L over pi R squared if it's solid, but it's hollow. Area in this case, it will be equal rho L over pi R out square minus pi R in square. It means A out minus A in. I can take pi as a common factor, so that R equal 1.62 times 10 to the negative 8. The length is 2 meter, and pi as a common factor. R out 3 centimeter divided by 100, it will be 0.03 squared minus 2 centimeter divided by 100, 0. squared, and use your calculator and get the answer. I will check with you. 2.06 times 10 to the negative 5 ohm. We can write it 2.1 times 10 to the negative 5 ohm. Question number 6. A nichrome wire with a length of and 1 millimeter radius, HR multiplied by 10 to the negative 3, is connected to 12 volt battery. It's delta V. What should the ammeter reading? We need current. The resistivity of the silver is 108 times 10 to the negative 8. This is for silver. First step, calculate the resistance. It's rho multiplied by length over pi R square, area. It's equal, rho is 108 times 10 to the negative 8 multiplied by length is 1.2 over pi R square by multiplied by radius square 1 times 10 to the negative 3 squared. The resistance equal, it's 0.413 ohms. The second step is I equal delta V over R. Delta V is 12 over the answer, 0.413. The answer is 29.08 ampere. In the figure, if the reading voltmeter when the circuit is open is 12 volt, so that this is the V battery before we connect it to the circuit. And when the circuit was closed, the voltmeter reading is 11.5. This is the delta V or potential drop across the resistance. And the reading of ammeter is 2 amp. It's current pass through the circuit. What is the internal resistance? Internal resistance, it's R small, question mark, it measured in ohm. Now we can calculate it in two steps. The first step, because R, the external resistance, R equal delta V over I, so that it's equal to 11.5. When the battery is connected to the circuit, it's 11.5 voltage divide 2 amp. The outer resistance is 5.75 ohm. Again, the voltage in this place is 11.5 voltage when the current pass through the circuit. So that I calculate this resistance, it's 5.75 ohm. The second step, the current equal V battery. V battery, it refers to the voltage before we connected the battery to the circuit. V battery over R external resistance plus R small internal resistance. In this case, we can write I is 2, V battery is 12 volt, external resistance is 5.75 plus internal resistance, it's unknown, cross multiplication, 12 multiplied by 1 is equal 12, equal 2 times 5.75 is 11.5 plus 2 times R small, it's equal to R. I can take this to other side with negative sign. 12 minus 11.5 is 0.5 equal 2R divide by 2 so that the internal resistance equal 0.25 ohm. Consider a battery that has VT, it means terminal voltage is 12. When it's not connected to the circuit, it means this is V battery before we connect it to the circuit. When a 10 ohm resistor is connected with a battery, it's external resistor, it means R capital, connected with a battery, the potential difference across the battery terminal drop to this is delta V after we connect the battery to the circuit, so that the voltage across the battery and the resistor is 10.9 voltage. What is the internal resistance R small equal what? The first step, I can calculate the current pass through the circuit from delta. It's a potential drop across the resistor divide R. It means 10.9 divide 10. It's equal 1.09 amp. The second step, we know that I equal V battery over external resistance plus internal resistance. I is 1.09 equal V battery is 12 voltage before we connect it to the circuit over external resistance is 10 plus internal resistance unknown, cross multiplication, mean 12 equal 10 times 1.09 is 10.9 plus 1.09 R, 10.9 to opposite side with negative sign. It means 12 minus 10.9, it's equal 1.1, equal 1.09 R. Divide by 1.09, divide by 1.09, so that R equal 1. Question 6.3. The quantity milliampere hour is equal. Milliampere hour. If I need to convert it milliampere hour, I need to convert it to what? Ampere, it means I, hour, it means time, it's equal the charge. So that if I need to convert it to coulomb, milliampere multiplied by 10 to the negative 3, hour times 10, 3,600, it's equal to 3.6. If 1 milliampere hour, it's equal to 3.6 coulomb. Okay, if I need to convert it again, milliampere, to convert it from milliampere to ampere, so that it means 3.6 milliampere to ampere, it means ampere, 3,600 to convert it from hour to second, AS, so that ampere hour. It's equal 3.6 ampere second, and at the same time equal 3.6 coulomb. So that the answer A is correct and the B also is correct. Question number 8.1. How will the equivalent resistance between the two point A and B changes if we remove one of the resistor? If we remove one, the equivalent resistance will be decreases. Why? Because it's in series connection, so that Req equal R1 plus R2 plus R3 plus R4. If we remove any of these resistor, the equivalent resistance will be decreases. 8.2. In opposite circuit, R1 is 6 ohm, R2 is 4 ohm, and the reading of the voltmeter is 3 voltage. What is the amount of volt drop across R1? We need to calculate V1. The first step, I can calculate the current pass through this resistor. How can we calculate this current? This is the first step, I equal delta V over R, so that it will be 3 voltage over 4 ohm. It means 3 over 4 amp. But this is what? This is a series connection. So that the current pass through R2 will pass also through R1. The same current pass through the two resistors. This is R and this is R. The same current pass through the two resistors, so that the second step, I1 equal I2 equal 3 over 4 amp. The third step, I can calculate V1 equal I1 times R1, mean 3 over 4 multiplied by 6. The answer will be 4.5 voltage. Question number 3. In the opposite circuit, the same circuit, this is 6 ohm, this is also 4 ohm. We calculate the current pass through the circuit is 3 over 4 amp. This is the current 3 over 4. And also we know that this voltage is 3 volts, and they calculate the another voltage is 4.5 volt. What is the amount of total voltage VMF? This is series connection in VMF equal V1 plus V2. V1 is 4.5 plus V2 is 3, so that the answer will be 7.5 voltage. The battery voltage VMF equal 7.5. The potential drop across the first resistor is 4.5. The potential drop across the second resistor 3, so that 3 plus 4.5 equals 7.5 volt. Question 8.4. 3 different light bulbs are connected in series with a battery. This battery delivers a constant potential difference VEMF. Which light bulb has the highest brightness? The highest brightness will be the highest resistance. Why? Because this is series connection. In series connection, the current is constant, so that I can calculate the power for each light bulb from this equation, B equal I squared multiplied by R, so that B directly proportional with R. If the R increases, the brightness will be increases also, so that the answer will be the bulb with the highest resistance.